Humanity's age-old dream of flying to distant galaxies is beginning to come true, but most of us don't even notice it. Why not? It is very simple. If we are not ourselves, then the creations of earthly cyberneticists, interplanetary flying machines, have long ago been furrowing space routes, and some probes have managed to leave the limits of the solar system. Many of you may have already guessed that this will be Voyager 1. This invisible hero is now about 20.9 billion kilometers from the Sun and fearlessly continues the path of the galactic warrior, moving farther and farther away from the Earth. Let's recall the main stages of the biography of the legendary apparatus, trace its route, and admire the best pictures sent by the probe from the farthest corners of our star system. Voyager 1 was launched 43 years ago on September 5, 1977. It was supposed to be no more than 5 years old, and its mission was to study in detail the appearance of Jupiter and Saturn, sending back photographic reports. The probe did its job perfectly, for the first time revealing the formidable face of the giant Jupiter with its turbulent atmosphere. Here, for example, is the enormous crater Valhalla, nestled on Callisto, Jupiter's satellite. Voyager 1 looked even farther, approaching the boundaries of the solar system. The apparatus captured tiny Charon in the shadow of its enormous neighbor Neptune. Voyager 1 had a twin, which departed 16 days earlier, but the apparatuses are doomed to eternal separation and will never meet again because their routes and goals are significantly different. Probe number 1 was given a short path, but in the end, all deadlines have passed and astronomers on Earth are still communicating with it. Moreover, part of the equipment of Voyager 1, in spite of the enormous distance, continues to work and transmit data to the center. The stuffing of the 798-kilogram probe at the time of its departure was considered top-notch. It is in good condition now. The Divas is equipped with a camera, which is currently deactivated to save energy, spectrometers, interplanetary plasma, and cosmic ray detectors, a magnetometer, 2 computers, and a photopolarimeter. As mentioned above, some of these instruments are still in operation today, but they would be of no use without the main components of Voyager 1, a powerful energy source and 2 sensitive antennas. The probe is powered by radioisotope thermoelectric generators using plutonium-238. The half-life of this element is about 88 years. So the time of communication with the apparatus is gradually decreasing. For comparison, during the flight, the source power was 470 watts. Near Uranus, it decreased to 400 watts, and now it has fallen to about 50% of the original level. In 5 years, this figure will decrease even more. By the way, before the decision was made to de-energize the camera, the device sent a photo that brought sentimental tears to the eyes of the NASA team. In it, the Earth looks no bigger than a pearl pixel, an insignificant speck of dust among the blackness pierced by cosmic rays. Voyager 1 took a photo of our planet from a distance of 6 billion kilometers in 1990. It went around the world and was called the pale blue dot. But it is not only the power supply that prevents the Earthlings from getting access to the valuable information delivered by Voyager 1. The alienation process is accelerated by the rapidly increasing distance between point A, Earth, and point B, the probe. But how long will we be able to pick up the signals sent by the spacecraft? And the second question is, how do we manage to do this, given that Voyager 1 is almost 21 billion kilometers from Earth. A signal with a power of 20 kilowatts flies to the probe for 24 hours. For comparison, to communicate with Mars, 15 minutes will be enough to send a message to the addressee. But with sending a signal in the opposite direction, from Voyager 1 to Earth, there are certain problems. The quality of information reception is considerably hampered by the weakening power of the davits, the inevitable scattering of the signal in space due to the huge distances, as well as the Doppler frequency shift. So how do scientists get out of this situation? For this purpose, there are ground-based deep space communication stations, and probes are equipped with highly sensitive sensors oriented toward the Earth. The Deep Space Network is NASA's long-range space communications network, which is charged with the mission of controlling interplanetary spacecraft and maintaining uninterrupted communication with them. It has only 3 stations at its disposal, but they are equipped with giant antennas, ultra-sensitive receivers, and super-powerful transmitters. It must be understood that information from distant probes comes in drips, no more than a dozen kilobits per second. But over the past half-century, space communication technology has been significantly upgraded, so now we can pick up signals from objects many light-years away from Earth. Are the ways of receiving signals from distant and near objects relative to our planet different? Yes, in principle, the boundaries of interplanetary space are defined by the International Telecommunication Union, assigning different frequency bands to objects. Distances Earth-Moon, Sun are considered to be near space, but deep space frequencies begin at a distance of 2 million kilometers. These frequencies are used in communication with Voyager 1. How long will this communication last? If the device had an inexhaustible source of energy, everything would look more optimistic. But in this case, in 5 or 8 years, we will no longer be able to hear the little messenger of distant worlds. After sending his farewell bid, it will disappear forever into the pitch darkness of the Milky Way. Where is the probe now, and what images it has managed to transmit to Earth? Since January 2012, the equipment Voyager 1 recorded a 25% increase in intergalactic cosmic rays, which means that the probe approached the boundaries of the heliosphere and will soon go beyond its limits in interstellar space. 3 years ago, scientists decided to run the probe's engines for a slight correction of the apparatus, and oh wonder, they succeeded, and yet the motors were not powered for 37 years. After 40,000 years, Voyager 1 will fly past the star Gliese 445 and go on an eternal journey through the universe. So let's take a look again at the legacy photos left by the spacecraft to our descendants. The rarest photo, the Earth and the Moon in one shot. This ball of fire is Io, the most active satellite of Jupiter, which has over 400 active volcanoes. And this is cold and dead Enceladus, the satellite of Saturn. Here is Saturn itself, photographed by Voyager 1 from a distance of 34,000 kilometers. There is a tab on NASA's website where you can follow the probe brothers in real time. Monitoring will continue until communications separate us. Thank you for watching. I hope you enjoyed this issue. If you did, and you're already waiting for the sequel, then mark it with your mighty cursor. It's very easy to do. You just point this thumb here and poke as hard as you can. Do that, and the universe will definitely reward you. And if we manage to get 30,000 thumbs up, I'm releasing a new, very, very exciting video right away.